In that homogeneous system of equations, we will look for one of the example, I hope. Yes. So let me share my screen here. I have to share my screen. I'm just sharing my screen here. Yes. So I was gone for homogeneous system of equations there. So for what is the difference between homogeneous and non-homogeneous system of equations? Anybody recall what is difference between homogeneous and non-homogeneous system of equations? Where right hand side is 0 there, in which system it is?
Homogeneous.
Homogeneous. Okay. For homogeneous system of equations, you can observe right hand side equations. Means I am having m equations n unknowns. Here I show you is m equations n unknowns, and right hand side you are getting all entry as 0. So I am having, this is homogeneous system, and whenever I am having certain constants there, combination of 0 and constants, I will have non-homogeneous system of equations there. Yes. So whenever I am having homogeneous system of equations contains, this is one of the system of equations which is homogeneous system of equations. For this homogeneous system of equations, I'll write this system in the form of Ax is equal to 0. Yes, I am writing this system of equations as Ax is equal to 0. And quickly I'm just going for this chart. Yes. So we know that for homogeneous system of equation, it is always consistent. So always consistent means what? Will have always a solution. System, homogeneous system will have always solution. Which, how many types of solutions are there? We are having only 2 types of solutions. Yes. One of the solution is trivial solution. Another solution is non-trivial solution. Trivial solution means what? Is trivial solution means what? For homogeneous system, I am having trivial solution whenever I'm having all the unknowns are 0. Yes. You can't hear me. Okay. Hello. I'll check my mic. Till now, everybody can listen. Everybody can listen. Students, can you hear me? C division, can you hear me?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
D division, can you hear me? Everybody is saying they are audible. So I'm audible, I hope. Yes. So for homogeneous system of equations, I am just writing the system in terms of Ax is equal to 0. So I am having always a solution for homogeneous system of equations. So I am having two types of solution: trivial solution and non-trivial solution. Trivial solution I can get whenever I am having rank of matrix is equal to number of unknowns. So for the trivial solution, whenever I'm having rank is equal to number of unknowns, we are getting trivial solution, that is all unknowns is equal to 0. Yes. How many unknowns are there for the system? Whenever I am having trivial solution, it means that all unknowns are 0. Then I'm having trivial solution. Yes, but our non-trivial solutions means not all unknowns are 0. Yes, or for non-trivial solution, I can have infinite number of solutions. Yes, so for a homogeneous system of equations, I am having trivial solution or I am having infinite number of solutions. Yes, only these 2 types of solution. Trivial solution, when I am getting trivial solution, when I am having rank of A is equal to number of unknowns, at that time I am just getting trivial solution. Yes, rank of A is equal to number of unknowns, I am having trivial solution there. Yes, but whenever I'm having rank of A is less than number of unknowns, I am having non-trivial solution or infinite number of solutions there. We were gone for second example last time. I hope the example is having large number of equations that I shown you last time. So this example I took last time, where this system of equations contains 5 equations and 4 unknowns. So this system of equations, I got to know that whenever I'm just looking for the question here, I am just looking that this system of equations are having all right hand side 0 and left hand side I'm having in unknowns there. So 4 unknowns, 5 equations, right hand side 0. So I'm deciding this is homogeneous system. We are writing this system in terms of Ax is equal to 0, and after writing this as Ax is equal to 0, we will going to use row transformation for converting A to echelon form. Whatever row transformation I am using, same row transformation I have to apply on right hand side. But for a homogeneous system, what I'm finding funny thing, that right hand side all entries are having 0. So whatever row transformation I'll apply, I'm having all entry for right hand side will be 0 only. Yes, this is the funny thing for homogeneous system. So I'm using row transformation for converting this matrix 5 by 4 matrix to echelon form. Yes, and I am using row sequence of row transformations here. I am getting this matrix now. Yes, I am having this last matrix here, and for this last matrix, we are just getting it is in echelon form. This matrix is having 4 unknowns. Sorry, this matrix is having 4 unknowns, and I find it in echelon form. I am having 4 non-zero rows. So rank of A is equal to 4. Number of unknowns also 4. Rank is equal to n. Number of unknowns is equal to 4. So whenever I'm having rank is equal to number of unknowns, this system will have trivial solution, means all unknowns are 0. So what I'm doing, I'm just multiplying this column matrix with each of this row, and I'm getting 4 equations. I wrote it here. These 4 equations I wrote it here. From last 4th equation, I'm getting x4 is 0. Substitute it in 3rd equation. We will have x3 as 0. Substitute x4 and x3 is equal to 0 in 2nd equation. You will have x2, x3, x4 as 0. Again, substitute it in 1st equation. You will have x1 also 0. Yes, so all unknowns we are getting it as 0. Just go for solving these 4 equations by back substitution way. What is mean by back substitution? Go for 4th equation, then 3rd, then 2, and then 1. This is called as back substitution way. So you will get all unknowns are 0. That is, we are having it as trivial solution. This example we already looked last time. So now I have to go for one more example, and it contains unknown, one of the unknown. That's why I just left this example. I told you that this example will go for taking afterwards, and now the time come, I have to go for that example here. Yes. So let us go for this example here. Determine unknown. I am having unknown small b. I require to search unknown small b such that the system of homogeneous equation has this system. Yes, look for the system here. This system is having 3 equations, 3 unknowns, and right hand side you can concentrate for right hand side all entries are 0. Yes. So this system is homogeneous system that I want to get it first, though it is mentioned in question, but sometimes in our question paper they will not going to mention. So I have to click in my mind just by looking for this question. I have to click in my mind that this system is homogeneous system there. Yes, this system require what we require. We require to search value for unknown b when the system will have trivial solution or non-trivial solution here. Yes, the system will have trivial or non-trivial solution. At that time, I require to search value for unknown b. Is find a non-trivial solution using matrix method. Trivial solution means what? I'm having all unknowns as 0. Which are the unknowns here? We are having unknowns as x, y, z. Is so I require this system should have trivial or non-trivial solution. At that time, I require to search value for unknown there. Yes. So let us go for first. I am having the system of equations. I'm having 3 equations in 3 unknowns, and what I find here, I wrote it as for trivial solution. We know that we are having x is equal to y is equal to z is equal to 0. We are having all unknowns x, y, z is equal to 0. For getting all the unknowns to be 0, what I will go, I will take any value for b. See, if I'll substitute b is any real number, positive real number, negative real number, fraction, is whatever I'm going to put, still I'll have x is equal to y is equal to z. I'll get definitely it as 0. Yes. So for getting trivial solution, I'll just simply write b can take any value. And my first sub question solution is over here. Yes, my first sub question solution will be over here. When I was going to write, I will going to write b may take any value. B can take any value. My first sub question solution will be over here. Yes, it may take any value, real, positive fraction, negative fraction, any value it can take. Yes. So now my second sub question. What I ask us for trivial solution, b may take any value. Now I have to go for non-trivial solution. Yes, non-trivial solution when it occurs, non-trivial solution, I have to check chart. Whenever I'm having rank is less than number of unknowns, at that time I'm having non-trivial solution or infinite number of solution. So I require rank of A should be less than number of unknowns. So I will go here. Yes, I'll go here for non-trivial solution. For non-trivial solution, I'm writing system of equation in terms of Ax is equal to 0 form. Yes, I am writing this system in terms of Ax is equal to 0 form. Just observe it. Yes. So now I will going to apply row transformation on this matrix A. Yes, I will apply row transformation on this matrix A. I'll try to convert this matrix A to echelon form. Same row transformation I have to apply on right hand side matrix, but as matrix there will be no any effect on 0 matrix there. Yes. So what I want, I require element at 1 1 the place to be 1. So I'll interchange R1 and R2. Yes, I'm interchanging R1 and R2 in first step. So now I'm getting element at 1 1 the place as 1. Yes, I have to use R1 to convert other element in column 1 to be 0. So I am using R2 minus twice R1, R3 minus 4 R1. Yes, so I am using that row transformations here. I am using R2 minus twice R1. I am using R3 minus 4 R1 for converting element in first column as 1 0 0. Yes, same row transformation. Still, if I'll use on 0 matrix, my matrix will remain as it is. Yes. Now remember that. Yes, for element in third row, though I am having entry as B, we will keep that entry as it is. Yes, so what I'm having R3 minus 4 R1, so I'll get this as B minus 4 into 3, B minus 12. I'm getting this entry. I'll keep this 3 the place entry as it is. Yes, further what I want to do, I can make, yes, now what I find, in column 2, I'm getting 2 entries as minus 1, minus 1. I'll make bottom entry to be 0 by doing R3 minus R2. Yes, I'm just going for doing R3 minus R2. And what I'm getting in column 2, now I'm having entry as 1, minus 1, 0 here. 0 here. For 3 the place, what I'm having, B minus 12 minus 4, that is B minus 8. I'm having this entry at 3 the place. And right hand side 0 matrix will remain as it is here. Yes. So now what I can do, I can multiply R2 by minus 1. Yes, I will going to multiply R2 by -1. So I can have this row as 0, 1, 4, and here I'm having 0 there. Yes, still, if I'll go multiplying this R2 by -1, I can have entry 0, 1, 4, and after that, I'll going to check what I'll have rank of this matrix A now. Yes, what I'll have rank of this matrix A. See, before guessing rank of this matrix, what should I got to know is I have to get to know that I am having two non-zero rows here. Yes, first row is having entry 1, 1, 3. Second row is having entry after or before multiplying -1. I am having 0, -1, -4 here. If I'll go for multiplying it, still I'm having this row as non-zero row. So I'll definitely get this as 0, 1, 4. कोणी लेक्चर चालू है. Still I'll have this row 2 entry as 0, 1, 4. So I am having two non-zero rows here. Yes. Now what about third row, students? What about third row? See, I am having in third row we are having entry as 0, 0 and B minus 8. Yes, B minus 8. I'm having this third row is having entry as 0, 0, B minus 8. Yes, depends on this B minus 8. I can say whether my row R3 is 0 row or non-zero row. Yes, so if I'm having B minus 8 is equal to 0, then what will happen for last row? What will happen to last row? If I'll just go for saying B minus 8 is equal to 0. Or whenever I'm having B is equal to 8, what I'll get row 3 here. What I can say for R3?
Rank 2.
Yes, rank will be 2 actually. But what I want to ask, whenever I'll go for saying B minus 8 is equal to 0, it means that my row 3 will be 0. Yes, my R3 will be 0 because already I'm having 0, 0, and whenever I'm just saying B minus 8 is equal to 0, it means that rank of, I'm just getting this R3, third row is 0 row here. As third row will be 0, I'll have two non-zero, I can say this is in echelon form. Yes, I can get this is in echelon form. But whenever I'm saying B minus 8 is not equal to 0, it means that my R3 is not equal to 0, and definitely I'll go for saying rank is whatever the things there. Yes, but here I'm going to remember that I require non-trivial solution. For non-trivial solution, I am just recalling chart. What I require for non-trivial solution, I require rank of A should be less than number of unknowns. Yes, I require rank of A should be less than number of unknowns. So number of unknowns, how many unknowns are here? I am having 3 unknowns. Yes, I am having 3 unknowns. Rank of A should be less than 3. So it should be less than 3. So rank may be 3. Sorry, rank may be 2. Rank may be 1. Whether you're getting me, students? Whether you're getting me?
Yes, ma'am.
Yes, so number of unknowns are 3. For getting non-trivial solution, rank of A should be less than 3. So as it is less than 3, it may be 2, it may be 1. Yes, but what I wrote it here, I wrote it here 2. Why I didn't wrote 1? Anybody can tell me why I didn't wrote 1? Why I'm not writing for non-trivial solution, rank of A is equal to 1, which is less than number of unknowns. Why I didn't rank of A is equal to 1?
Ma'am, the above matrix we consider in echelon form, that is B minus 8 is equal to 0, so that the rank will be 2.
हाँ बोलो.
Ma'am, there are 2 non-zero rows.
Yes. Yes. That I want to ask. That I am having expected answer. So already look for this matrix A. I am having first row is having entry 1, 1, 3, which is already non-zero row. Second row is having entry 0, -1, -4. So I can't go for saying anything for both of these rows. Both of these rows are non-zero rows. So that's why we are just saying rank of A is equal to 2. If rank of A is equal to 2, we can make B minus 8 as 0. We can make B minus 8 as 0 so that I can have only 2 non-zero rows. Third row, if I'll go for having entry B minus 8 is equal to 0, this third row will be 0 row and rank of A will be definitely it is 2, which is less than number of unknowns. So as rank is less than number of unknowns 3, so definitely you will have non-trivial solution. For getting non-trivial solution, I must have to equate B minus 8 is equal to 0 and I'm having value for B is equal to 8. So like that way, sometimes they may ask you, I told you previously also, university likes the pattern of questions where unknowns are there. Sometimes unknowns may be lambda, mu, b, a, and the other things are there. So university love this pattern of examples here. So any doubt here? Any doubt? Yes. So see, for this is the example I am just taking for homogeneous system of equations here. Is homogeneous system of equations. This pattern of this example I took it right now here. Is before that I was gone for non-homogeneous system of equations. So right now what I took till now that I want to tell you. I want to open this PPT here. Yes. We were started with matrices. Yes, in matrices, after that, we were gone for revising the thing and we were started with uh, complex matrix. Yes, in complex matrix, we were looked for Hermitian, skew Hermitian matrix. For Hermitian matrix, we were just wrote A is equal to A raised to theta. And whenever I'm having A raised to theta is minus A, we are getting skew Hermitian matrix. After that, what I was gone for, I told you that 4 to 5 theory examples are there. 4 to 5 theory examples are there. Just wait. Excuse me, student. हेलो मेरा लेक्चर चालू है तो आप आधे घंटे के बाद में ट्राई करो. राइट नाउ आई एम हैविंग लेक्चर. इन लेक्चर विल बी अप टू 3:15. Yes, after 3:15 you can go. Hello, I'm sorry student. Yes. Hello, can you hear me students? Okay. So we were started with matrices. We were just gone for introducing complex matrix, and further I was gone for homogeneous. Not homogeneous. I'm sorry. We were gone for Hermitian, skew Hermitian, unitary and orthogonal matrices. Yes, we were gone for those definitions. Further, I told you that 4 to 5 statements are in such a manner that this type of statement, so that every square matrix can be expressed as symmetric, skew symmetric. Every square matrix can be uniqueness. Then we are gonna, sorry. Just wait. I hope. till this PPT will going to come. Till that, today itself in the morning, I shared with you one more PPT on matrices. Remaining thing I shared with you regarding matrices, and we were looked right now one of the word file which contains homogeneous and non-homogeneous system of equations. If you look Google Classroom, that so now I can go for we've gone for some of the examples we were gone for show that every Hermitian matrix can be expressed B plus IC, where we require B to be B to be real symmetric and C to be real skew symmetric. And this one more example I gave you in tutorial. So in tutorial right now I am hello.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Now just wait a moment. Hello, D division. Can you hear me now? Hello. Okay. Now I have to share my screen again. I have to share my screen. Where I was actually, see, as we were gone for unitary and orthogonal matrix, then we were started with, in place of going for sharing the that PPT again. I hope again some problem may create. So in place of that, sharing with that word file for homogeneous non-homogeneous system of equations and rank PPT I shared with you in the morning. So after that we were started with rank. So rank is one of the important topic. Definitely 6 to 8 marks questions will be there on rank. Questions are in such a pattern that find simply rank of matrix. So whenever we are having this type of question, what you will going to do, you will going to convert that matrix to normal form. This normal form you will going to convert and just find rank. Yes, don't go for converting it to echelon form, but you have to convert it directly to normal form and just write rank. Further, what I told you that PAQ form. Yes, PAQ form is the further version of normal form. Just write right hand side as identity A into identity. I explain you what to take order for pre-multiplied and post-multiplied identity matrix. So all these things are related with rank. Further, what we were gone for? We were gone for system of equations. Is homogeneous system of equations, non-homogeneous system of equations we were gone for. So Ax is equal to B and Ax is equal to 0. I am calling sequentially those systems as non-homogeneous and homogeneous system of equations there. For non-homogeneous system, we are having 3 pattern of solutions. No solution, unique solution, infinite solution. Remember again, I'm just repeating chart. That chart is too much important. This chart is useful for finding, is for require to write values of unknowns. Yes, whenever we are going for the chart, at that time only I got to know what will be the values of unknowns there. Yes, so it is too much important to remember chart regarding non-homogeneous system of equation and homogeneous system of equation. Because see, why I am just forcing to remember that chart, because based on that chart only your unknown type of examples are solutions of unknown type of examples are based on that chart only. Yes. Yes, I'm not, Prasad, I'm not sharing my screen. I'm just talking. I'm just talking with all of you. Yes, because already I just shared all the things of PPT, all PPT of matrices, all Word file of matrices I posted in Google Classroom there. Just look Google Classroom, study it properly for tutorial 1, tutorial 2 also you have to go for, but just go for studying for yourself that PPTs and Word file. Yes, so still if you're having any questions, you can ask doubts after completing my lecture. Will be there in the lecture, online lecture only, for clearing your doubts. Now further I'm just going for next, I'm just going for successive differentiation. Now how much part, see, most of the time most of you are asking me, ma'am, what is the syllabus regarding class test 1? We don't know, you and me also don't know when our class test 1 will be. For class test 1 definitely we will have matrices, and if I'm going to add that successive differentiation, till what I will going to add, definitely I'll share with you before the class test there. Yes, so let us go for a PPT of depends on successive differentiation. This successive differentiation little bit I'm going to add for class test. Yes, I just ended with matrices. It doesn't mean that, see, there are still other, so whatever the topics are there according to syllabus, I just shared all the topics with you regarding matrices there. Now further, I'm not going to talk regarding matrices. I have to go for next topic. And next topic, what I told you, next topic, now I am just going for successive differentiation. One of the chota topic hai, is that I want to go for. Yes. Before going for that, now I forgot again, I have to share my screen. So I'm just sharing my screen now. Yes, I have to share my screen here. See, but regarding matrices, still there are variety of example. All of you have to go for studying matrices now yourself. The topic is over, it doesn't mean that doubts will be over. Definitely those who will going to solve example, they will definitely have doubt. Those who will not going to solve anything, they will never have doubt. At the last moment only they will going to look for the things, and it will be difficult for them. Yes, so go for studying examples on matrices simultaneously. I'm just going for now next year. Now I'm just going for slideshow mode. I'm just going for slideshow mode here. My screen is visible, I hope. Successive differentiation is one of the small topic here. Yes. So 6 to 8 marks questions will be asked on successive differentiation, or sometimes a short example of 5 marks may be asked in question number 1. Yes. Successive differentiation is having two parts only. One of the part where they will going to mention some function and you have to find nth derivative for that function. It may be in Cartesian, it may be in polar form. Yes. And the second part, very much important part, is Leibniz theorem. Depends on Leibniz theorem. Each and every question paper will have 6 marks question definitely. Again, I'm saying 110%. One of the question Leibniz theorem they will going to ask. So none of you will going to leave Leibniz theorem. Yes. Now I have to start with successive differentiation here. Yes. It may be, see, sometimes it may be 6 to 8 marks, sometimes it may be 12. Sometimes it may be 12 marks. 2 questions may be asked or only 1 question. So if I'll consider 2 questions, so it may be for 12 to 14 marks. Yes, you can consider 12 to 14 marks weightage is there for successive differentiation. Okay. Matrices, it is one of the last topics, so right now I can't tell you, but 3 to 4 questions may be there on matrices. 3 to 4. Yes. So if I'll consider 3 questions, so 18 marks or more than that weightage may be there. So see, previously when your syllabus was started, at that time, one of the PPT I was having for marks distribution, that PPT again, I will going to share with you weightage PPT, I will going to share with you in Google Classroom. Yes, so your doubts will be clear there. Yes. So for weightage PPT, I will going to share with you, or screen I will going to share with you in Google Classroom. So now I'm just going for a small topic, successive differentiation. So what is mean by successive differentiation? Successive differentiation is the process of differentiating a given function successively times and there is n times, and the result of such a differentiation is called as successive differentiation. The higher order differential coefficients are at most importance in scientific and whatever it may be. Let fx, I'm just saying, see, I'm just considering one of the function fx. Let fx be a differentiable function and let its successive, एक lecture चालू आहे, lecture. इथं हे चालू आहे ना, मग लेक्चर चालू आहे, 15-20 मिनिटांनंतर मी बोलेल. Okay, sorry students, sorry. I'm sorry. Let fx be a differentiable function and let its successive derivatives be denoted by f dash x, f double dash x, f triple dash x, and so on. Nth derivative here, nth derivative of x. Common notation is how we are denoting successive differentiation is if I am just having, see, what I told you that I am just having this function y is equal to fx. I hope now my arrow can be visible here. Yes, I am just having certain function y is equal to fx. Yes, so if I am having certain function y is equal to fx, then the derivative of y, I am just writing derivatives of y as y1, y2, y3, y4, y5, and so on. I'm just writing yn. Yn means nth derivative of y with respect to x. Yes. One more thing I want to tell you here. Yes, what I want to tell you here, y is equal to fx. When I'm considering this function, so I am just denoting this function by y, and it is having how many variables is this function is having? How many variables this function y is equal to fx is having? Yes, it is having only one variable. Yes, only one variable, and that variable is x. Yes, so whenever I'm having certain function y is equal to fx there, and when I'm differentiating y is equal to fx, definitely you will have dy by dx. Yes, so whenever I'm just going for differentiating y is equal to fx there, I am having first derivative. Hello student, can you see my screen, or am I audible also? Okay. So when I'm differentiating this function, I am having dy by dx. Yes, I'm just denoting it by dy by dx. This is first order derivative. And I'm just denoting it by y1. Yes, I may differentiate this dy by dx again second time. So I'll going to write d2y by dx square. Yes, I'm just having d2y by dx square and it can be written as y2. Yes, when I'm differentiating it third time, then I'm just getting d cube y upon dx cube and it is also written as y3. Yes, so like that way, for the same function y is equal to fx, I am having y dy by dx as y1, I am having d2y by dx square as y2 and d3y by dx cube as y3. When I'm just going for differentiating n number of times, dn y upon dx raised to n, it is denoted by yn. Yes, so like that way, today here in this topic, we are just studying function having only one variable. It is denoted by y is equal to fx. We are differentiating that function n number of times, and we are developing certain formulae here. Yes. So just I'm just showing this notation. Further, I wrote it as whenever I require to search derivative of that function at x is equal to a, it is just denoted by dn y upon dx raised to n at x is equal to a. Yes, notations and formulae. There are different formulae for searching derivatives of finding function. Yes, certain fixed function there, and I'll just develop certain formulae. So whenever they will going to ask y is equal to certain function and find nth derivative, that is yn for that function, at that time I'll just go like this way. Is one of the function. Yes, again I'm just denoting a common notation. First derivative, common notation for higher order derivative for the function y is equal to fx as first derivative, I'm just denoting it by f dash x, or it is y1, or it is written as dy only. Second order derivative, I'm just denoting it by f double dash x, y2 or d2y by dx square. I'm just having nth derivative, I'm just showing it like that way. It is just the notation I want to show you. Yes. Now, whenever I want to go for searching nth derivative for certain function there. So see here, I want to go for finding nth derivative for certain function. I am having that function as e raised to ax. Yes, one of the function I'm just taking one of the function y is equal to e raised to x, and I want to search nth derivative for this function here. So how I have to proceed? So what I'm doing here, I'm just differentiating y, e raised to x. When I'm differentiating, what I'm getting first derivative, you can observe I'm having first derivative as a e raised to x. Differentiating e raised to x, we are having e raised to x into derivative of a into x is a. Yes, when I'm differentiating again it, you can observe we are getting a e raised to x into a, derivative of ax. So, let me clear the screen, clear it, and then I'll try to explain you. So whenever I want to go for derivative of e raised to x, all of us we know how to go for derivative of e raised to x. So e raised to x remains as it is into derivative of x. I'm having a. Again I have to differentiate a e raised to x. So definitely you will get this as e raised to x into previous a I already had in y1. So a into derivative of e raised to x, I am having e raised to x into a again I have to go for. So that's why for y2 I am having a into a as a square e raised to x. Yes, if I'll go for differentiating it again, so what I'll have y3 is what I'll have y3. So a into a I'll have a square into derivative of e raised to x. So I'll have e raised to x into derivative of x will be a. So I am just getting y3 as a cube to x. Just observe. Yes. So see, y1 I'm having a into e raised to x y2 I'm having a square e raised to x. In a similar manner, I'm just having y3 as a cube e raised to x. Can you guess what you'll have y4? What you'll have y4? Yes, you will have y4 as a raised to 4 e raised to x. y5 will be a raised to 5 e raised to x. So like that way, I'll just proceed for searching nth derivative. I am not searching, I'm not differentiating it n number of times. After 1 or 2 or 3 derivatives, I can guess what will be my yn. So for this example, I am directly guessing here. I am having yn as a raised to n e raised to x here. Can you get it, student? Do you get it? What I want to tell you is, do you get it? Whenever I'm having function y is equal to a raised e raised to x, I can guess what I'm having nth derivative here. Just by calculating y1, y2, y3, I can guess what I'll have yn. So like that way, in this topic, we will going to guess if I'm having y1, y2, y3 are in such a manner, then what I'll have nth derivative for certain functions there. I'll not go for differentiating it n number of times. I'll not go for using 100 or 200 pages for searching nth derivatives there. So this topic include the questions are in such a pattern that they will going to mention certain function and they will ask us to find nth derivative for these functions here. I'm just stop sharing my screen here today and I'll go for taking your attendance right now. C division, I